Hi, this is part 2 of a series on trigonometry, and in this one we're going to cover the unit circle, 3 trig identities you need to know for the ACT, and a few special right triangles that can come in handy. But before we get to the unit circle, let's cover 2 things. First, the 30, 60, 90 triangle. What are these side lengths? Let's find out by drawing it and then reflecting it across that line right there, and you get something like this. This was a 90-degree angle, so that's going to be a 90-degree angle. So this is a straight line, right? This was side length 1, which means this reflection is going to have side length 1. And since this is 30 degrees, this is 30 degrees. Since this is 60 degrees, this is 60 degrees. 30 plus 30, 60. This is 60 degrees as well. So this is an equilateral triangle, meaning this whole side is 1, meaning this is 1/2, and this is 1/2. So now we know this side right here is 1/2. Assuming the hypotenuse is 1. So what about this side? Let's use the Pythagorean theorem for that. Let's call that x. Then we have x squared plus 1/2 squared equals 1 squared. A squared plus b squared equals c squared. So now we have x squared plus 1/4 equals 1. So x squared equals 3/4. Take the square root of both sides. X is going to be equal to the square root of 3 over 2. So in a 30, 60, 90 triangle with a hypotenuse length 1, this side's going to be 1/2, this side's going to be square root of 3 over 2. Got it? Good. Let's move on to the next one. How about this right triangle with a hypotenuse length 1 and 2 45-degree angles? What are these side lengths? Well, since each angle has the same measure, each opposite side will have the same length. That's one of the properties of an isosceles triangle, which this is. So using the Pythagorean theorem, we get x squared plus x squared, if I can write, equals 1 squared. A squared plus b squared equals c squared. So that means 2x squared equals 1. Divide both sides by 2. We have x squared equals 1/2. Take the square root of both sides. And we have x is equal to, you could say 1 over the square root of 2. But a lot of mathematicians don't like to have an irrational number in the denominator like this. So let's just multiply the top and bottom by the square root of 2. And we have this is equal to the square root of 2 over 2. These are 2 triangles that are used a lot in the unit circle, which we're about to cover. So you got to have these memorized. The right triangle, that's a 30, 60, 90, with a hypotenuse length of 1, has the side length opposite the 30-degree angle equal to 1/2. The side length opposite the 60-degree angle is square root of 3 over 2. For the 45, 45, 90, with the hypotenuse length 1, you got square root of 2 over 2 is the length of the other 2 sides. Got to have those memorized. All right? Good. Let's move on to the unit circle. All right, let's just assume this is a circle. The circle has a radius of 1 all the way around, okay? Now, let's draw a few other lines here. Assume this is a 90-degree angle here for the x and y. And let's draw a 45-degree angle, okay? And let's draw a 30-degree angle. So this is 30, that's 45, and let's say that's 60 right there, okay? I know it's not perfectly drawn, but you get the gist of it. Over here, if this point right here is on the x-axis right here, what is the coordinate of that point in the xy plane? Well, it's going to be xy, 1 in the x direction, 0 in the y direction, right? 1, 0. What about this point right up here that's on the y-axis? Well, it's going to be 0 in the x direction, 1 in the y direction. 0, 1. Okay? So what about these others? Where this is 30. I'll call this 30 degrees, 45 degrees, and 60 degrees. Okay? Now it's hard to read, but you get the point. This point right here, this point right here, this point right here. Well, it's 30 degrees. If you drop a line down, this is going to be the x distance. This is going to be the y distance, right? Well, we already did that. This is a 30 degree. This is a 90, so that's got to be 60. That's this triangle. This point will have the x distance of the square root of 3 over 2. And a y distance of 1/2. Look at the 60 over here. It's the same thing, just inverted. It's the same triangle, just now this is the 60-degree side here, and this is the 30-degree side up here. So this one is 1/2 square root of 3 over 2. This guy right here is the 45 degrees, which means if you drop a line right here, this is also 45 degrees right here. So this is the 45, 45, 90 triangle. So this is square root of 2 over 2 over square root of 2 over 2. The x direction, just like this is square root of 2 over 2 long. Since the radius is 1, this is 1. This is square root of 2 over 2 as well. Another way, if you want to do this very quickly without thinking it through like the triangles, check out this video. I made that a while back. Watch it. And you can draw this very quickly, especially if you had to on some scratch sheet of paper or something. You could at least get the first quadrant very, very quickly. Just watch that video to figure it out. But the rest of these all around, if we go this way, so we go 90 plus 45, 135 degrees. If we go 90 plus 30, so that's 120 degrees. If we go 90 plus 60, that's 150 degrees. These points over here are just mirror images of these points with the x being negative. So this will be negative square root of 3 over 2, 1/2, negative square root of 2 over 2, square root of 2 over 2, and negative 1/2 square root of 3 over 2. And this point all the way over here, well, you go 1 in the negative direction, and you don't go anywhere in the y. So this is going to be negative 1, 0. Then you take the reflection going this way to get all of the y coordinates if you need to go down here. So this would be 180 degrees plus 45, 180 degrees plus 30, 180 degrees plus 60. Well, you can just draw these over. Minus square root of 3 over 2, minus 1/2. Minus square root of 2 over 2, minus square root of 2 over 2. Minus 1/2, minus square root of 3 over 2. This point down here, that's going to be 0 in the x direction and minus 1. So that's going to be 0, minus 1. Then if you want to go all the way around, this is 270 degrees plus 45. And let's say that's a plus 30 this way, plus 45, and plus 60. So these points right here, well, it's going to be positive in the x direction, negative in the y direction. So just flop this down. This is going to be positive square root of 3 over 2, negative 1/2. Positive square root of 2 over 2, negative square root of 2 over 2. Positive 1/2, negative square root of 3 over 2. That's the unit circle. And then you can figure out what all these angles are as well, like I was just explaining earlier. So you may be wondering, why do you need to know this? Why do you care? Remember this guy over here? What is the definition of sine of, say, 30 degrees? It's going to be opposite over hypotenuse. Well, that's 1/2 over 1, which is just 1/2. How about the cosine? The cosine is this side over the hypotenuse. So the adjacent side over hypotenuse, which is square root of 3 over 2 over 1, which is just square root of 3 over 2. In other words, if the radius or the hypotenuse is 1, which this whole thing, that's what we have, then the y direction is the sine and the x direction is the cosine. So for any of these points, that is cosine of x, that is sine of x, where x is the angle. Let's use theta though, usually use theta. So if the angle is 0, we haven't gone anywhere, then cosine of 0 is 1, sine of 0 is 0. Got it? Cosine of 30 degrees is square root of 3 over 2. Sine of 30 degrees is 1/2. Cosine of 45 degrees is square root of 2 over 2. Sine of 45 degrees is square root of 2 over 2. Cosine of 60 degrees is 1/2. Sine of 60 degrees is square root of 3 over 2. And if you go up 90 degrees, cosine of 90 degrees is 0. Sine of 90 degrees is 1. And then you can add on another 30. So 120 degrees, there's your cosine, there's your sine. Add on 135 degrees, so this is going all the way to 135 degrees, minus square root of 2 over 2, and square root of 2 over 2, and so on. So if you need to know the sine and cosine of all these different angles, the unit circle gives them to you. And these are very practical, used angles. They come up a lot, so it's good to just be able to rattle this off really quickly, or draw it very quickly, or just have it memorized, or just, go from there. So now that you have all this, you're going to need to kind of memorize this, or at least be able to figure it out very quickly. So let's use it to solve a few things they may ask for on the exam. What's the sine of 135 degrees? Pause the video, resume when you're ready. Well, sine of 135 is, well, the 135 degrees is 90 plus 45, so that's this guy right here, and sine would be square root of 2 over 2. What's the cosine of 225 degrees? Ready? Well, 180 degrees plus 45 would be 225 degrees, and the cosine, these are both minus square root of 2 over 2, so it's going to be minus square root of 2 over 2. How about the cosine of 120 degrees? Well, again, 90 plus 30 is 120, so the cosine is minus 1/2. What's the tangent of 315 degrees? Well, 315 degrees is also 360 degrees minus 45. So that's going to be right here. And the tangent is opposite over adjacent, in other words, sine over cosine. So that's going to be minus square root of 2 over 2 over square root of 2 over 2. Which is just minus 1. What's the cosine of 240 degrees? Well, 90, 180, 270. Let's back up 30 degrees. We're right here. So the cosine is minus 1/2. Hopefully you get the point. But if you know this, you can do this very quickly. You don't have to go to your calculator and have it do it for you. But especially if you have your calculator do it for you, most likely, depending on how your calculator is set up and configured, it'll give you, instead of root 2 over 2, it'll give you it'll give you a decimal place going out 10 decimals, and that may not be what they're asking for. They actually will give you answers, A, B, C, D, and E, that have roots in them. Square root 3 over 2, square root 2 over 2, minus square root 2 over 2, all those kind of things. So it's just good to know this stuff. If you know it offhand, it can make those kind of problems that come up every now and then go a lot quicker, go a lot faster. Just makes the whole thing smoother. I mean, you can always put this stuff into your calculator later if you need to. If you need to know what the decimal representation of square root 2 over 2 is, feel free to shove it into your calculator. But if they give you a bunch of answers that have roots in them, it's good to know this. Let's move on. All right. There are 3 trigonometric identities you should know and have memorized like the back of your hand, and they are sine squared of theta plus cosine squared of theta equals 1. You got to know that. Why is that true? Let me give you a little bit of intuition here. Let's go back to a mini unit circle. Whee! Look at any point here. Let's say this is angle theta. This right here is going to be the cosine of theta, sine of theta, x and y coordinates right here. Okay, because cosine for the unit circle, this is the unit, is x, sine is y. Well, for this, adjacent over hypotenuse is just the cosine, and this is just the sine, the opposite over hypotenuse. So, what does the Pythagorean theorem tell us? This side squared plus this side squared equals 1. Right? That's this side squared plus this side squared equals 1. It's just the Pythagorean theorem applied to trigonometry. Now, does this work for any theta? Yeah, doesn't matter. Positive, negative, more than 90 degrees, doesn't matter. It always works. And I'll leave that to you as an exercise for you to prove if you would like. For now, just memorize this. Know that. Second thing you need to know. If this is the first thing, let's say this is 45 degrees or something, doesn't matter. That's the same theta right there. And you just flip it around to negative theta. So you have positive theta this way, you have negative theta this way. What is this point down here? What's the cosine? Well, it's still the same x value, right? So it's still going to be cosine. In other words, cosine of negative theta equals cosine of theta. They're the same thing. Doesn't matter if you go up 45 degrees or down 45 degrees, the x-coordinate's still the same. Now the y-coordinate's different, which is why the third one is the sine of negative theta. How do you think that relates? If this goes up that high, what's down here? It's just a negative of it. Negative sine of theta. So if you go down 45 degrees, that value is going to be the negative of if you went up 45 degrees in terms of the y-coordinate, the sine. And that happens for any of these angles, all the way around, doesn't matter. I'll give you $100 in Monopoly money if you can disprove any of these. Know these. How would they be used on the ACT? Well, they may ask you something like this. Simplify sine of negative theta over negative cosine of negative theta. And they'll give you A is -1, B is 1, C is tangent theta, D is cotangent theta, E is minus tangent theta, something like that. They give you a bunch of options. What is it? Well, if you know these two, sine of negative theta is just negative sine of theta. cosine of negative theta is just cosine of theta. So this cosine of negative theta is just cosine of theta, so we're just stuck with still the negative sign out here. Cosine of theta. Negative signs cancel, and we're left with sine theta over cosine theta, which is just tangent of theta. So you choose whichever option has tangent of theta, and you're done. There's lots of other examples I can give you, but I'm not going to do those here. Just if you know these three and you see something with a cosine minus theta, you know that's the same thing as cosine of theta. If you see something with sine of minus theta, you know that's a negative sine of theta. No, sine squared of theta plus cosine squared of theta is 1. You should be good to go. Now let's move on to some special triangles that you should know, you should have memorized, and you should be able to work with. There are these that I've had in some other videos, but in case you missed those videos or whatever. All right, these are three you should definitely have memorized. The 3, 4, 5, the 5, 12, 13, and the 8, 15, 17. I would say 80% of the time they use a special triangle on the ACT of the ones I've seen, it's the 3, 4, 5. They'll have variations of it. It could be everything times 2 or times 3 or times 10 or something. 30, 40, 50, 6, 8, 10, who knows, but they use this one a lot. The second used one is probably this guy, 5, 12, 13. I've seen it a couple, 3 times, and I've seen this one once or twice. Definitely know 3, 4, 5, be able to spot it, especially different things on it. It's just one of those things where you don't have to figure out what the side length is. If you know this is 3 and this is 4, you just know that's 5. You don't have to sit there and work out the Pythagorean theorem. So, 9 squared plus, or 3 squared equals 9. 4 squared is 16. 9 plus 16 is 25. Oh, square root of that is 5. No, you don't have to do that stuff. You just say, 3, 4 is 5. 5, 12 is 13. 8, 15, 17. Know these. There are others too, if you really want to go down that rabbit hole. There's a lot of them, actually. There's these two, the next two, in terms of smallest integers, the 7, 24, 25, and the 9, 40, 41. I have not seen a single question that uses any of those yet. So I don't think it's worth your time to go and start memorizing all these other special triangles. But these 3, 3, 4, 5, 5, 12, 13, 8, 15, 17, yeah, it's likely one, if not more than one of those will show up on the test in some way. So have those memorized. Know how to use them. Know how if they give you 3 and 5, and this is a right angle, and they ask, what's the tangent right away? Well, this is a 3, 4, 5 triangle. So the tangent of this angle right here is going to be 3 over 4. You don't have to mess around and do anything else. You just be able to spot right away as a 3, 4, 5 triangle. As long as that's a right angle, this is 3, that's 4, 5. Or if that's 4 and that's 5, this is going to be 3. Just be able to do that right there. It'll save you a lot of time. Next ones. Remember this guy? 45 degrees, 90 degrees. If this is 1, then these two sides are going to be square root 2 over 2, square root 2 over 2. It's on the unit circle. That's very helpful in figuring out what the sine and cosine are. So if you're having to figure out what's the sine of 45 degrees, well, it's going to be square root 2 over 2. But what if you're dealing with scaling up or scaling down of this triangle? You have a similar triangle to it, and you're trying to figure out the side length or the sine from there. Well, a variation of this that may come in very handy, a variation of this guy, same angles, 45, 45, you assume that's a 45 and a 90. If you just multiplied this by 2 over root 2, 2 over root 2, 2 over root 2, well, this becomes 1, that becomes 1. This is 2 over root 2, which then if you multiply top and bottom by root 2, you'd have, if you did that, that equals 2 root 2 over 2. 2's cancel, and it's just root 2. This is just root 2. This is sometimes more helpful when you're trying to scale it up. So if you're given something like, hey, they're giving an isosceles triangle where each side length is 8, what is the side length over here? Well, it's just going to be root 2 times 8. So it's going to be just 8 times root 2. So this is a special way of looking at this. This is great for trigonometry. This is better for similar triangles or triangles where you need to figure out the side length very quickly. Well, it's better to think of this triangle more in this form, where if these sides are 1, usually, but be able to go either way. Remember the 30, 60, 90 triangle? This side is going to be 1/2. If this side is 1, that makes this side square root 3 over 2. We did that. We proved that earlier with by drawing the other triangle down here, equilateral triangle, yada, yada, yada. A more helpful way to think about this one sometimes is if you just scale it up by a factor of 2. And this becomes root 3, 1, and 2. So if you see a triangle where this side's basically half the size of this one, well, you just need to know you need to multiply this by root 3 to get whatever it is. So let's say they give you a triangle where they're saying this side is 20, this side is 10. What is the length of that side? Well, it's just going to be root 3 times this, so it's 10 root 3. If this is your 1 now, that's going to be root 3 times it, so whatever that side is, 10 root 3. So this variation is good when you're doing similar triangles, or, I mean, it's not good. It's not good versus bad, it's helpful in the situations where you have to figure out what the side lengths are for different scaled up, dilations of this triangle. This is great for, this point on the unit circle, going around, what are the coordinates? Well, it's going to be, 1/2 square root 3 over 2, or square root 3 over 2 1/2 if you flip it over the other way. So, but this is better when you're dealing with, things out in the wild sometimes. So just be able to work with them, be able to notice it right away. Oh, this is a 30, 60. Oh, okay, another way to think about this is this side's going to be twice this side, and this side's going to be root 3 times that side, times the small side. So that's it. 2 last topics. When it came to the special triangles earlier, let me just circle back to that. The 3, 4, 5, 5, 12, 13, and 8, 15, 17. Not only don't go and try to memorize anything else after that, just get used to doing the Pythagorean theorem on other types of triangles. If you have to do the Pythagorean theorem on a triangle to figure it out, you most likely have to use the Pythagorean theorem to figure it out. It's not going to be something simple. It's going to be something with an irrational number on one side. It's not going to be one of those special cases. Usually, at least from what I've seen, it's not worth your time to memorize it. Instead, get really fast at working out what a particular side of a right triangle is using the Pythagorean theorem if you know the other 2 sides. Okay? Other thing, make sure you know how to use your calculator. You got to know sine, cosine, tangent, arctan, arcsine, arccosine, also known as tan inverse, sine inverse, cosine inverse. You also got to know your cotangent, your secant, your cosecant. Know where all those things are on your calculator. Also know where pi is on your calculator. Know how to get the square root of something very quickly on your calculator. If you have to get the decimal representation of square root 2 over 2, you need to be able to do that very quickly. Know how to use your calculator is what I'm saying. Your calculator is your friend. I'm a big fan of not having to use a calculator, as you can probably tell, but on this exam, the calculator's there. It's good at calculating things. Use the calculator and know how to use the calculator. You'll be very limited on the test if you don't know how to use your calculator. It's kind of like trying to be a roofer without knowing how to use a nail gun. You can be up there going ding, 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 when you could just go jink, 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 jink. That's a lot faster. Using a calculator in a lot of situations is a lot faster. This is a time test. Use your calculator. Know how to use your calculator. Practice using your calculator. All right, that's all I got for this time. Hope this helps.